Hello class, we're back to the product mix example. In the first video we built the spreadsheet model and we formatted it. Second video we built the optimization model on top of the spreadsheet model using solver. And now this third video is about sensitivity analysis of the model. And so what happens if we change inputs? What does it do to the product mix? What does it do to the profit? Those are the kind of questions you want to answer with sensitivity analysis. We did mention at the end of that video that it would be, again, very time-consuming to try to change manually. We found that the labor for assembly constraint is binding. And so we think it would be very time-consuming to come change that and then rerun solver and keep changing that and rerun solver. Every time you change a blue cell, you would have to rerun solver. So the author of the book wrote an add-in, and the add-in is called solver table. The instructions and the zipped file on how to get it installed on Windows, and we said it doesn't work on the Mac, are on Blackboard, so you can find them there. If you follow the instructions and you add it in, it comes up with its own ribbon. And so the ribbon is to run solver table. There is a help menu. There is who created it. And if you ever want to get rid of it and unload it from the ribbon, you can unload it here. Solver table is think of it as a very fancy macro. Okay, but it wasn't built with a macro because macros are simplistic programs. It was built using Visual Basic for Application, the VBA language for the Office suite for Excel. And so if you want to do something fancy beyond what a macro can do, you can do it in the language of programming language of Excel, which is VBA. And this is what this author did to create this. And the idea for this add-in is to come to an input cell and change it, and then run solver in the background. Then change it again, run solver in the background. Keep changing it until it's done. So it automates the task, which a macro is supposed to do. It mimics the one-way data table and the two-way data table for spreadsheet models, but it goes beyond it, and it runs solver in the background. Data tables do not work for optimization model. You have to use solver table for that. And so this example now, we saw that this is binding. The labor hour for assembly is binding. So we are interested in doing sensitivity analysis on that. If we increase it or decrease it, labor shortage, or we increase it, hire more people, how would that affect the mix? Number one, how would that affect the total profit? And so that's what sensitivity analysis would answer. So we run solver table, and it gives us a warning message like, do you already have a spreadsheet model and an optimization models? There should be a solver item on the far right of the data ribbon. Make sure solver is set up. Well, we just did that in the previous video, and we got the optimal solution. So we say yes. And then it gives another dialog box. So this is even more fancy than solver itself, which comes with Excel, because now we're seeing these are called forms in programming. Each of these dialog boxes is a form, actually, built in the VBA language. So now, are you doing one way or two way? One way means you're changing one input and looking at the solution. Two-way means you're doing changing two inputs and looking at the solutions. And so we just want to change this assembly labor hour. And I think you're asked to change it between 8,000 and 12,000 in increments of 500. Now, the example in your book may be asking for a different cell to change and gives you the range and the increments, but we're going to change this 10,000, vary it between 8,000 and 12,000 in an increment of 500, which means 8,000, 8,500, 9,000 until we get to 12,000. So we click OK. And I already set this up for you, but it works just like the dialog box of Solver. You will get an empty dialog box, and you would have to fill it the way we filled Solver. So if the input cell was empty, we say, what is it that you want to change? Which input cell you want to change? So I just click on this, and it gives me the name of the cell if we named it. Then we have three options. We get a base input, minimum, maximum, and increment, or we put values in a range and we can use those, or we just list some values here. Again, this is more than data tables of Excel provide to us. Data tables, you have to set the ranges, as you saw in a previous chapter, ahead of time, and they have to be equal increments. Here, the author of this add-in even went beyond and is giving us three options. So these numbers were not there, so we enter them. 8,000, 12,000, 500, we're picking this option. And this is where you have the output cells. One thing I would warn you against is that these output cells, if I want more than a couple, more than one, I have to separate them by the comma, but you don't type the comma. So here I'm saying I want to see the mix, the 560, 1200, how that changes, and I want to see D25, which is the total profit. So if I try to type these and then type comma and then type this, it doesn't work. It replaces it. It's based on Excel, where if you are picking non-adjacent ranges, you have to hold down the control key, and it would type the comma for you. So I will select these, hold down the control key with my other finger, and then select D25, and it inserted the comma and added that. That's something some students have trouble with. So I click OK. Notice that it ran all these values. It changed the labor hours between 8,000 to 12,000 in increment of 500, and gave me how much to produce of the XP and the basic and the XP, and the total profit. So this is a scenario in business that is very normal for sensitivity analysis. You want to see what happens if we have to decrease the labor hour or we have to increase them. How would that affect my profit? A confirmation for you is this. Right here, we had 12,000. What was the original? 10,000. And it was 560, 1,200, and 199. So you come here, when it was 10,000, we got the same answer. So this is definitely working. When it ran it with 10,000, it gave us the original optimal solution. So these are cells. So you can do calculation, like percent increase of profit. I can write a formula here and calculate the percent increase. Say this is this minus this divided by the 167. So that would be a calculation that you do over and above the solver table. Here, it gives you a chart, one for each of the output cells. So the charts are useful, but you can do your own charts too. So if I select the total profit, it's saying that it starts increasing, and then it reaches a max of 200,000. Why does it reach a max? Because other constraints max out, like the maximum sales. And so we're not going to increase the profit. At some point, when we reach 10,500, we can do more. And so 600, 1,200. After that, those are the maximum sales constraint. So they are the same. And so it doesn't matter how much you increase labor, it's going to give you the exact same solutions. And this is extremely helpful for management, because otherwise they keep throwing money on the problem, increasing labor, but the total profit is really not increasing at all. And so that's the sensitivity analysis for this problem. And I will finally end with about this problem with how you can build a decision support system, DSS, for the problem. So if you're using this, you're an analyst and you do a nice model, you can use VBA to build an interface in Excel so that your manager or your colleague doesn't mess up the formulas. You hide them, you hide the model in the background, and you build these buttons, again with VBA programming. And so view inputs, you put a nice explanation, you make a form that gives the input, and then you also say, okay, the inputs are correct, I don't want to change them, and then you click on Optimize with Solver, and you see that it will give you the report. And so that was done with VBA programming language, very useful for analysts. You can see the models that are, the model itself is like the one we just did, but it was hidden. So I just used it to unhide. We don't cover this in this class. It's more advanced, but the MIS students would be interested, or even the finance students, if they want to incorporate more programming into their model. So that finishes the product mix example. I hope you enjoyed it. We'll cover other examples in future videos.